All right. So all students currently in this class wants to ensure that they're a part of this group. All right, and this group is going to be very important because we want to make sure that we can exchange information that we will need to this semester. All right. So I'm going to go ahead and go to Skype, and let's go ahead and call Dr. Sudukar. Dr. Sudukar, how are you?
Hey,
Hey, how are you?
okay, fine. It's dark here.
Okay, that's okay. That's okay. So I have you on screen share with my class currently, so they're able to see what I see.
Uh,
All right, the students will be able to see the screen that I'm seeing you from. So
okay.
we would like to say first of all, thank you for agreeing to meet with us today. I really appreciate
Okay.
that. And I guess the all that I wanted to assure for the course currently was to make sure that all the students that are on the line that they have their accounts um, properly activated with Galaxy and 16.
Yes.
Okay. So I'm gonna try to talk with the class right now to see if all the students currently in class have their accounts together, and I'm gonna try to get them to move. I just made a group, and I'm hoping that they
Light
will.
is on,
Okay.
so a little bit visible. Yeah.
I can see you better. Good to see you again. Thank you.
Nice.
Thank you so much for agreeing to work with us once again. Okay. So would it be? I guess I'm gonna talk to the students. Can you guys hear me in Teams?
Yes.
Okay.
Yes.
Okay. Good. Good. Has
I could have joined the teams also, but anyway.
do you want me to just do you want to try it? You want me to send you the link to Teams? That'd be
Then we are all in the same place.
Yeah,
Right?
we'll-
Instead of you Skype and this and that.
okay. Okay. That might be better. Yes, sir.
Yeah. Okay. You send me the Teams link. I'll join there and then I'll shut off this Skype.
Okay. 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 Give me 1 sec if you don't mind. Let me get the link to the class.
You can stick it into the chat here. That link.
Okay. All right. I just sent it to you.
Okay. Okay. Let's see. Okay. Okay. Let's try that. Open link. It's going somewhere. I don't know where it went. Does it work? Maybe it is starting to do something. You have to be patient.
Okay.
Um, so is there something like a sign up type thing there? Or?
I think I can add your email address to the team and probably will send you a link as well.
Yeah, yeah, it is PA. Okay, let me type that into the chat. My email, you probably know my email address, but
Okay.
I will just put it into the chat in there. No, I got I clicked on it, but I don't know what is happening. EU.edu. So that's my thing. Let me click on this join conversation. Microsoft Teams, yeah. Open link, I said. Oh, it is trying to open something. See what happens. Because I'm logged into Teams already.
Okay. All right. I think a link should have got sent to your email. Hopefully.
You sent another link to that email.
Or I think Teams automatically will do it for me. But I added you into the course.
So send me a push. I should get a push here. My phone. Oh. What happened? Get a push. Let me cancel them. Let me again. Then. Oh, that's what I have to do. Okay, let's see. This kind of spinning. I don't know what that means. Oh, it's going somewhere. Okay, so I see an email. Let's see if the email link works. Microsoft Teams. Stefan added you. Organic chemistry qualitative analysis. Open Microsoft Teams. If I do that, what happens? So I say accept. Okay, hang tight while we give you access to Alcorn. Okay, open. Want to switch to Alcorn state? Yes. It's coming up. Okay, so I'm in some group. Do you see me?
I do.
Meeting now. Okay, I'll say join. Okay, there I am. See. Okay, I say join now.
Okay,
You let people in the meeting know you are ready.
I just did.
Okay, stop this.
Okay, I'll start Skype as well.
Okay.
Great.
And here.
Yes.
Hello, everybody. Can you hear me?
Yes, hello. Yes, sir.
Good. So are there any who have signed up in Cgrid and cannot see the Gaussian 16 application?
Can you repeat that?
Are there any students who signed up in cgrid.org? When you log in, you should see the Gaussian 16 application. Usually there is a star beneath that application, tablet. If you click the star, it will become your favorite application. And maybe, Stefan, you want to share your screen and point to that cgrid.org website?
Sure.
That way everybody sees what I'm talking about. Okay, so if you, so you go to dashboard, and then if you, there is a star here, right? And if you click on the star, it should come to the top of the list. And it is set as one of your favorites. And all others are in non-favorite set. So it should come to the top. That way, when you log in, it is right on top. So the question is, can everybody confirm that they have this Gaussian 16 on the top? Oh, I see some people are creating logins. Let me quickly check. Or they have already logged in. Ashley has not. Let me check if they got the. Okay, let me see. Ashley. Okay, I'm going to enable Ashley right now, and Ashley should be ready. Okay, who's next? Nikita, I think Nikita already has an access, I believe. Yeah, Nikita is ready. So anybody who cannot do it. It's like everybody is able to do this. Is that right?
I don't know about everyone else, but I can't see what you're doing.
Okay, so this is who's this?
Okay, so I guess the question is, you cannot see my screen right now?
Yeah, so I don't know if that's just my Wi-Fi acting up or if that's everyone.
Okay, I'm gonna.
I see the screen.
Okay, you guys can see.
Okay, so maybe that's just me
Yeah.
then.
I'm gonna stop sharing and reshare to see if that clears things up.
Okay, I'm enabling Jenny. Again. Who else? I believe I enabled everybody who has a login from Alcorn at this point. So if anybody cannot do this, I think I should hear from them. So how many students are there in the class, Stefan?
I see 15 students right now. 15.
15?
Yes, sir. How many accounts are activated?
Yes, please.
Dr. Cooper, I'm not able to favorite the Gaussian application. So I have it on there, but I don't know how to bring it to the top like you did.
There is a star in the bottom. Can you select the star? Click on the star.
Thank you.
Got it?
Yes, thank you.
Okay, good. Anybody else?
I'm sorry, which group was it that we were supposed to favorite?
That there is a Gaussian 16, an application named Gaussian 16. And if you click on that star, which is usually gray, if you click it, it will become blue, and then the application will migrate to the top of the list. Right? So for example, I'm going to ask Stefan, who is sharing, to, for example, click on the gray star under Abacus 6-13-3. 6 dot, can you do that? Yeah. If you click that, and then you scroll up, see Abacus is now part of his favorite list. If you click that blue star again under Abacus, Stefan, it will go away. It will go to the bottom. Yep. So Gaussian 16 remains as the favorite. This is just a way to bring the applications that you typically use to the top of the list.
That's great.
So while you are doing that, I'm going to ask some general questions. Is it raining there?
Not anymore. Last night is when we got some of the heavy rain.
Okay, good. Yeah. Yeah, I heard that in Atlanta, there were a lot of power outages and trees on the street and stuff. So you're doing okay, right?
Yes, we're fine. Thank you.
Good. Okay, so I saw another email. Let's see. Okay, let's see who else has got it. Okay. Kudakwashe Murunda. Let me make that login. Okay, yes.
All right, I'm going to interject if you don't mind, Dr. Sudhakar. Just to kind of just let the students know, we're trying to take advantage of this time now to ensure that your guys' accounts are activated.
Yeah.
What happens if after today, if you guys want to start your computational work and you don't have access to Galaxy 16, it's going to be a big lapse in your project where we have to email Dr. Sudhakar and hope that he has the time to find your account and activate it. But he was willing today to take the time to.
Yeah. Don't worry too much. I mean, yeah, you should send me an email, and if I am awake and on the computer, I will do it immediately. So yeah, I enabled, I think most of the students at this point. I mean, is there anybody among the 15 that are online that doesn't have a login on cgrid.org? It looks like everybody has one.
Okay, great. That's really good.
And is there anybody who cannot bring that Gaussian 16 up to the top of the list? Like what Stefan is seeing or showing in the shared screen. Yeah, that's it. Okay, I can stick around. Yeah, I see another account probably created. Let's see who it is. It is Taya Jackson. Let me make sure that Taya has access. Okay. Okay, Taya should be ready. And okay, so you probably have figured out that there is an email sent and you need to confirm and things like that, which probably most of you have done already. So yeah, let me stick around and maybe I think Stefan, you should probably continue with your class.
Okay.
I'll be around for a little bit and see if anybody needs help.
Okay, that sounds good.
Yeah.
Dr. Sudhakar, thank you so much. I really appreciate it again. Thank you. Thank you. Okay, students, let's kind of move forward with what we need to do. I'm going to go back really quickly to each person's assigned molecule just to make sure that everyone knows what that data is at. Is there anybody in class that doesn't know their assigned molecule currently? Is that yes, no, no, yes?
I know mine. I think
Okay.
I just made an account with Cgrid.
Okay. I think Dr. Sudhakar should be, he's in the background working on that.
Can you, yeah, please refresh your screen if you just added your login or confirmed your email. I just activated Vanessa Valentine.
Okay, great.
Yes, that's me. Thank you.
Good.
All right, I'm gonna open up the file with the assigned molecules, and then I'm gonna open ChemDraw. We're gonna talk about the assignments, and then I'm gonna build a molecule. I think I built the molecule last class, but we'll actually build a molecule and submit a job today. Dr. Sudhakar has given us a new resource, computational resource, and I checked it last night and worked on one of my jobs. So we're gonna submit one today.
Right? That's how he be feeling in the house.
Oh, hello, somebody speaking. Okay, I'm trying to figure out why I can't find assigned molecules. All right, so before I move forward, I want to make sure we are recording. So this will be a great resource for students that need to go back and look at this. All right, everyone in class should be assigned a molecule. All right, there's going to be two parts of this exercise. All right, but synthesis wise, this is the only one that's required. All right, but computationally, you're gonna compute for this molecule and the second molecule. All right, you can synthesize the second molecule, but that will be for bonus points. All right, and there's been some students that have been asking about ways to get their grades up. That could be a great opportunity to ensure you have the grades that you want, is by just doing both synthesis projects. But you can, the first is the only one that's mandatory for this semester. All right. Any questions there? Okay, good. No questions there. I'm going to bring up ChemDraw and let's kind of look at one of these molecules in details. Let's look at the second molecule in detail and let's figure out what exactly you guys are going to do. I think everyone is comfortable with the fact that we want to compare experimental data from computational data. You're going to make a story near the end of this course. And the whole theme here is computational chemistry relevant, right, to what experimentalists would need to do? Or I guess a better way to word that is it needful now to go in the lab, right, to make a molecule, to get the IR, to get the UV vis? Can the computational or could the computed structure give me the same data? And if so, then that means that computational chemistry could be a very good tool. And if not, then we see that there's still a need for us to actually be experimentalists and actually prepare the molecules. Right, so that's the whole goal. So first things first, the first molecule that you guys will have to make and also compute will be this hydrazone. Give me one sec. Preset line set. Okay. All right, and for a show of hands really quickly in teams, can you guys see my screen and hear me? Or am I just talking to myself right now?
I can see it.
Okay, I got some people said they can see. Is that most of the class can see? Is there anybody that cannot see right now? Okay, so let everyone can see. Hope that wasn't a message for teams because I'm not able to look at it right now. But somebody joining teams.
No, I just said I'm leaving, but you can ping me if needed. Okay.
Okay. I didn't realize that was your message. Thank you.
Yeah, I just sent it to the whole chat, I think.
All right. Thank you so much, Dr. Sudhakar. I really appreciate it.
Yeah. So yeah, welcome to the Gateway, and I hope it's a nice experience.
Can I ask one thing before you leave, Dr. Sudhakar? I'm so sorry.
Sure. Yeah, please.
I wanted to know if it's possible. What's the easiest way for students to move into the group I just created? I just made a group. I'm not too sure.
Yeah, you made a group, right, already?
Yes, sir.
You can, for example, which group is that?
It's just at Alcorn State University, Chem 410.
Yeah, so, okay, so edit the group. Can you click on the edit?
Okay.
And then here,
Just search for numbers.
yeah, you can search for like try Alcorn, Alcorn, and then it should give you a list of people. You know, you can click and add them one after the other, or all of them, or something.
Okay.
Yeah, they are all there. Yeah, you can make them members. I think they will be automatically added to the group.
Okay, this is a student from last year. I only see 2 students.
Yeah, you can remove them if they are not members any longer. You can delete them also.
Right.
Yeah.
I'll do it that way.
And you're welcome to make me a member of your group.
Okay, I'm gonna do that right now.
Okay.
Oh, okay. Here we go.
Yeah.
Is it which one I use?
Okay. So if you say yeah, the Paramedics at iu.edu, that should be good. Yeah.
Okay. Thank you.
Okay. And yeah, so you can also remove the old members, you know, if you think they are not relevant anymore. Okay. Just, you know, click on that dustbin type thing at the end. It says remove. Then that will get, you know, you can remove them like that. Okay. Anything else before I leave?
I think that's all for now. Thank you so much.
Yeah. Don't hesitate to, you know, contact me if needed. Okay.
Will do.
Okay. Good luck. Bye.
Thank you. Okay, let's go back. So once we come back to Cgrid, I guess I'm gonna have to ask students for their usernames. I'm not too sure why. I'm only seeing 2 Alcorn emails, but we'll work around that shortly. Okay, so let's go back to ChemDraw really quickly. And I think some people just joined the line. I'm not too sure. If you haven't, please go ahead and create an account in Cgrid. We wanted to make sure everyone's up and running, just so that we don't lose too much time with trying to get your account activated to be able to complete the job for this semester. All right, so for all students, you're going to have a combination of one of these 2 molecules. Give me a sec here. I'm trying to draw them out. All right, the nitrile group is going to have this framework. And you know if you're the nitrile group because your molecule has that nitrile name. Or you're going to be the keto ester group. It's going to have this look. All right, and some of the data you guys are going to collect computationally and experimentally is going to be an IR spectra. Right? And computationally, that's just the frequency. Right? That's a second derivative of energy. You get the frequency. All right, there's another molecule, and this is the second part of the computational stuff. But you guys are not required to synthesize it, but you can if you want. It's actually another day, just one extra step. You reflex it for about 3 hours to get to the next molecule. All right, you're going to make this compound called a pyrrozole. I'm going to put just, there's going to be an arrow group here, depending on what compound you condense with. Just give me 1 sec here. I need to make this a little bit smaller. Okay, so the nitrile will convert to this form. And the keto ester, we actually have an hydroxyl group here. All right, these two compounds are not necessarily the stable states. So instead, these compounds can also persist as all right, these compounds here to make the version from the keto ester. Something's off here. Okay, let's zoom out. So the second half of the project is really trying to figure out, if you try to synthesize it, which form or which tautomer are you going to be in? Are you going to be in the azyl tautomer? And this is called the azyl tautomer because of this nitrogen-nitrogen double bond. Let's talk about, let's go ahead and kind of get that together. All right. Versus, still got some back here.
So, Dr. Cooper, can I ask a question?
Yeah, go ahead.
So I see you're using ChemDraw. Is it free? I
No.
mean, do you have a license? Oh, so we need a license to have it.
Yeah, I don't have a, so I have my own personal license. The school doesn't really, yeah.
Okay.
Yeah,
That's okay.
we've been trying to work so hard on that. I have a strategy with like giving us access to a server to where we can put a perpetual copy on the server and then have you guys VPN. But that's been just a mystery for the university. They seem not to move forward. But there are some free software that you guys can use that would pretty much do the same thing. But there's
Okay.
no way that I could teach organic without access to ChemDraw. So I just personally buy it myself to get a license per year.
Okay.
Hope that answers your question.
Yeah, it does. It does. Thank you.
Okay. Good. That's a little too late, actually. Right, versus this version of it down here, which is going to be your hydrazone form or hydridyl form. All right, and so this is where computational chemistry is going to come in. How do we know which form we have? Right? So you can compute, you guys will have to do this part. You will compute for, if you have the nitrile, you're going to have the amino. You're going to compute this version of the molecule, which is the azyl part. And also you're going to get a IR frequency for the hydridyl part, or the hydro part. And you're going to compare the frequencies. If you synthesize it, the compound, then you're going to tell me at the end of that project which form you have. Is the compound, when it's synthesized, in the azyl form, or is it in this hydro form, or this azidyl form. And these two compounds are tautomers of each other. And I'm surprised. I've been looking in the literature and I realized that this form is, in a lot of cases, present. There's a nice hydrogen bonding effect here that kind of makes this favorable in some solutions. Not saying that the azyl can't hydrogen bond with an H here. It looks like it's done a little bit better in these systems. But some of the systems that you guys are studying are not the exact ones in literature. So actually, I don't have a clue to which form will be preferred. But you guys will just compute properties for both and give the values. So on the data sheet that you have, and it's going to be hard to draw in this version right now, I'm going to ask you some very specific things. I'm going to ask you for the frequency of this carbon nitrogen double bond in your structure. If you have the keto ester, it'll be the carbon oxygen double bond. All right. I'm going to also ask you for some information about the nitrogen bond, right? Can you tell me something about its distance, etc.? And then when you guys have these two other molecules to report, I'm going to be very interested in the frequency here versus the frequency here. And if there's any frequency between this carbon nitrogen or the carbon hydrogens and et cetera for that. We're trying to take advantage of the key differences between these two molecules. And I guess you would say just kind of tabulate that data and then be able to compare it later to a synthesized molecule if it's there. If not, it's okay. We'll have that data on hand. All right. So hopefully that makes some sense. I'm still trying to write everything up. It's just take some time to kind of get all the images because I'm trying to also help direct you guys on how to do your jobs in Gaussian. But I'm going to do one live today. All right. And then I'm going to have the instructions up a little bit later. Hopefully they'll be up by the weekend so you guys can get started on this. All right. So let's go ahead and get started. Let's go ahead and say that I'm going to move this to the side. I'm going to actually, I guess I'll do both versions of the compound. All right. So my phenyl ring doesn't have anything on it. No one in class has a bare phenyl ring. There should be some nitro groups, a methyl group, a methoxy group, a bromine, or something on your ring. All right. So I'm going to do the simplest version of this molecule. So the first thing you're going to do, and there's two ways that you guys can get access to Avogadro right now. Actually, we're going to do mode file first. Sorry. You can either come to campus to 213, that's not 213, 211, the computational room or a computer room, instrumentation room, I guess you would say, slight instrumentation room. And those computers, there's like 3 computers that have Avogadro already downloaded. Okay. And CTIS is going to be here tomorrow as well to just make sure everything is working correctly. So if those computers don't have internet access, just bring a flash drive, save everything you need, and then you can take your data back to your personal machine or to a machine on campus in the library and go ahead and submit your job computationally. So the first thing I would do, if you want, I would go to mode view.
Mhm.
Dr. Cooper?
I think he's gone.
I was definitely
If
wondering why I couldn't hear him.
Yep.
Yeah, I
if
thought
he's
it was just me
still
too.
Yeah,
on
He
the
was sitting
call,
there.
I all leave,
I
guys.
I thought it was just me.
Yeah, I left it and
Yeah.
then came back. I still can't hear
Wait,
anything.
am I the only one that's still lost on what he talking about or want us to do?
No, you're not the only one.
Just
Oh,
making
his
sure.
mic is muted, so
I
maybe you
have
should
no
mute
idea.
his mic.
so
It's the way I'm
Y'all, I have
probably
no
finna feel.
clue.
It's for me.
I don't
Dr.
have
Cooper, is that you laughing?
what's going on.
Oh,
So like how long should
He don't have much longer in the class, so
Do I hear Dr. Cooper?
I talked to him. Well, I went to talk to him earlier, y'all, and he said that the computational part, the part that like we got to do in the lab and bring back to him, is due on the 22nd. But the rest of it is gonna be due in sometime in December. So
What do
I
we
don't
have to
know.
do first though, like to get to that lab part?
He said he gonna give us whatever unknown we have, and we gotta come to we have to come to the lab and work something out. He said he was gonna explain it better to me today when we was in class, but I don't know that as far. He just told me we're gonna have to come to the lab and work some stuff out because we're gonna have to bring him back a solid. And he also said that we're gonna have to go back to doing the IR spectra again in that room we were in, as
Mm-hmm.
far as our data as well. But other than that, he didn't say anything more that I could understand a little bit better to try to explain it to y'all.
I'm not trying to be funny, but has he gotten his results back yet? Because I know he said if he tests positive, one thing gonna happen, but if he tests negative, we're going back in the lab.
He's in his office.
Yeah, I
He's
need
in
to
the
know
building
that
now.
too.
Like I just went to go see him a few minutes ago.
Oh,
I don't
okay.
know if he's even gotten tested yet.
Yeah,
Okay
he
then.
definitely. Y'all, so is class over?
And that's
Not
what
sure.
I was asking. Cause I don't think we're gonna do anything.
I think if we all sign off, we all can't. That's what I'm saying.
I agree.
So no one wants to sign off first.
I do it. Bye, y'all.
Okay. Bye.
So are we just gonna stay on here?
I don't know, y'all. He was talking, and I don't know what happened. I mean, I don't even know if he's still in his office. So I don't know.
I'm gonna stay for 5 more minutes and I'm gonna leave. And I just realized it's still recording, so it's picking up everything we saying.
Mine said that the recording has stopped, or now it's at the top is saying it started, but it stopped a while ago and then restarted.
It was in the woods. You gotta go kill it again. Hold up, you're gonna tell me this whole time you guys could not hear me in Teams. Why didn't anybody say anything?
Dr. Cooper, we were saying, are you hello? We were like, hello,
I
hello.
didn't. I didn't hear anything. I was teaching. I literally was teaching this whole time.
Oh, did you record it?
I don't think it's recorded because I didn't realize I got kicked out of Teams.
Yeah, cause somebody said they left and then they still came back and it was still like no value. And we were like, hello, hello,
I didn't
are
hear
you here? And
anything.
but it still showed that your face was on here.
Yeah, because I'm logging from two devices. My iPad was. I used to do all this. I let students in, but this whole time I was teaching on this main machine. I can't believe that. And I was like, "Can you guys hear me? Can you guys hear me?" And
We were
nobody said.
talking to each other trying to see if anybody heard from you and everything. And it was no nothing. So everybody kind of just left.
All right, I
Is it
need to
any way,
start.
Dr. Cooper, you can do like a self-recording of explaining how to do it? Because when we were just talking, everybody knows like as far as logging in, but we don't know how to go about handling the project itself. Does that
Yeah,
make sense?
yep,
And I
that's
tried to
what.
explain to them what you and I discussed, but I don't know if they still got it because I was still trying to ask some questions myself on how to go about doing it. So I don't know.
Okay. Sorry for the echo. I just can't believe I was teaching that whole time. All right, I'm gonna try to add everyone to join back. This is not the first time this happened to me in Teams.
Dr. Cooper.
Hey, I didn't realize y'all didn't hear me in teams. I didn't know.
Oh my goodness.
I literally was teaching this whole time until I said,
You
"Can
didn't hear us calling your name and talking to each
I
other?
didn't hear none of that because what happened, my iPad is on mute because I can't have the double volume. So I was teaching from the main computer, and all I heard was beep beep beep, people coming in and out. And so like I'm trained to just like go to my iPad and let you in. And then I was like, "Can you guys hear me? Can you guys hear me?" And nobody said anything. I said, "Am I talking to myself this whole time?" So then I go look for Teams. Okay, where's Teams on this computer? And I saw nothing. Then I was like, "Oh boy." Nobody saw any of the things I were doing. So I literally taught for like 45 minutes of like how to build your molecule and all that. I don't know what part of this lecture you saw and what part you did not see. I am so sorry about that. This is gonna make today pretty weird, I guess. In the last 15 minutes, let me just go back to what I was trying to do. Let me ask this question first. Can you guys see the screen? No, you can't.
No, we can't see it.
No.
No, we can't see nothing.
All right, it's coming.
No.
Give me 1 sec. I'm trying to get there. I'm so sorry. I cannot believe you guys couldn't hear me. I can't believe I was teaching for all that time. All right, can you guys see now what's going on?
We can see it now.
Okay. So I literally taught you guys how to build this to myself. So I can't go back over that part, and it didn't record because it wasn't on this machine. My iPad was still on recording, but it was recording nothing. It probably recorded you guys talking to yourself. I apologize for that. So let me say this. This is kind of what we want to be able to do. There's a sequence that I went through. So first, it's closed. I built a molecule in mold view because it's easier. I get this thing here. I can convert it to 2D and I get this structure. And I go to tools and I save as a mold file. You guys still with me in Teams? Did I lose you in Teams?
Yes, we here. We with you.
Just
Yes, we're here.
All right. So I saved that file in my folder that I created for the class, which is computational practice. All right. So then I go to Avogadro, and there's no way around this. We'll need this software. So access to the software currently is in 2.11. But if you have a machine and you want to download it yourself, it is free. You can download from the web. It's your choice. Just make sure that when you guys, if you're going to use 2.11, that you use social distancing, I guess you would say, in that room. Okay. So once you have the file open in Avogadro, you want to make sure everything's okay. Typically, I do a very short optimization. Just hit the E, tell it to start, and it was trying to minimize this based off of Vesper. All right. There's no high level quantum mechanics calculations, but Vesper is good enough to get you something to start with. All right. Then you want to move to extensions and you want to click on Gaussian. All right. And from Gaussian, you want to go ahead and save your files needed for computation. I'm sorry, I'm just adding some more people to join just to make sure I get all students in class. All right. This right here is the working line. This is like your code, I guess you would say if you were a coder. This tells the supercomputer what to do. So it says use the B3-lip theory, which is a DFT theory. Use this basis set, which is describing molecular orbitals, and then do an optimization, but on top of the optimization, do a frequency calculation. The frequency calculation is what is going to give us the IR spectrum. But the frequency solves a different question as well. And it's going to solve the fact the structure that is computed, is it a minimized structure? And what does that mean? Minimized just means that is this a ground state structure, a real thermodynamic structure? If it comes back with imaginary frequencies, and that's typically numbers that are negative, that means that the molecule that you're computed for is not a ground state molecule. Instead, it's probably a transition state. And the only way to knock it out of that is to find where the error is located and try to stretch that bond or to make it shorter. So typically sometimes there's an H that got out of position and you just kind of make it longer than it should be. And then you ask the job to recalculate. And the next time it calculates that structure, it tries to optimize that H to the ideal location to where your whole molecule will be a ground state. All right. So this is why computational stuff takes a little bit of time, because the data you get back from it, you got to make sure that it makes sense. And some of the cues that we use are checking the frequencies, making sure they're not imaginary. I'm going to bring up a frequency calculation here shortly, all right, for one that I calculated. Now, once I go ahead and open, have the structure in the background, go to the extension, go to Gaussian, and have my input file, and conveniently, you can tell it what type of calculation. We're going to do frequency today. You can change the theory. You can change the basis set, all that kind of stuff. You click on generate. I'm not going to do that now because I already did that. All right. So once you have the Gaussian input file, and keep in mind, my set of instructions that will be coming, they're going to try to hopefully help you guys direct your thoughts there. We need to generate a Gaussian file, and that's why we need Avogadro. All right. Once we have the Gaussian file, now we are ready to go to SeaGrid. All right, is everybody still with me in Teams?
Yes, sir.
Yes, sir.
Yes.
Okay,
Yep.
just checking. All right, I'm gonna go to my dashboard in SeaGrid, and I'm gonna click on Gaussian 16. Please ensure that you have Gaussian 16 enabled. Dr. Sudhakar, that's pretty much his number one reason why I wanted him on the line today, to make sure that everyone has this program ready to go. Go ahead and click on your Gaussian 16, right? We just made a Gaussian file. So that means that that file is readable by this software. Go ahead and browse for it. So I'm gonna hit browse. It's gonna be in my computational practice. I'm gonna choose the Gaussian input file. Hit OK, right? You can use a default allocation, that's fine. Now the machine that you want to use, or the supercomputer, is going to be the Expanse. We used to use Comet at San Diego State, but something's up with that one. So now we use Expanse. And Expanse just got created 2 days ago. So Dr. Sudhakar gave us access to this supercomputer. Looks like for this course, he actually told me to play around with it. If something goes wrong, he wants to be able to troubleshoot. So that's great that we have this machine to ourselves. So you guys should be able to get your jobs done really quickly. We don't have to share it with other universities, right? Well, we at San Diego State, not only does the researchers at San Diego State use it, but there's a lot of other people from other universities that also use it. I was using it for a while, and that's West Coast. I'm here in the Midwest, or in the Southwest, I should say. Okay. So you want to click on this next area here, and you want to go ahead and change the time. The nodes are fine, and the core counts are fine. Again, this is for like high-level research when people are trying to compute things like very big proteins and all that. We're asking for very routine IR, UV-Vis, spectra. We don't need this much computational stuff. However, the jobs probably don't take 30 minutes. It might take a little bit longer. So I usually put in about 120 minutes. And for memory, I'll probably put in 100,000. All right, I'm not going to submit this because it's already running in the background. Sorry, I put 100,000. Right, but once you have all this together, you will hit save and launch. And once you do, actually, you know what? Let me go ahead and do it. It doesn't matter. Let me change the name here. I'm going to hit save and launch. Okay. And you should see created, and that should move to executing. You can click in your workspace tab up top here, and you will see your jobs executing. All right, this is the job I did where I thought I was talking to students in Teams, and this is the job here I'm doing now. Okay. So the first part of this was supposed to get you guys comfortable with drawing your molecules in whatever program that you want to use. Sorry, somebody asked to join. Curating your Gaussian file and then using SeaGrid to insert your Gaussian file and submit it for a computational job. Okay. There are going to be some other codes that you guys will have to use. I will give you all of those codes, and I'll teach you guys how to modify your Gaussian files to do the other calculations that we need to do. There's going to be one other calculation you have to do for each molecule, and that's to get a UV vis spectrum. All right, and there's a special code for that experiment to be used computationally. All right, so the next thing I'm going to do here in the last remaining minutes is that how do I, once I've done all my computational jobs, how do I get the data that I'm asking for, right? Dr. Cooper is saying, where are the carbonyl stretches at? Where's the nitrogen-nitrogen double bond? Where are the nitrogen-hydrogen bonds and all that kind of stuff? Where are all those bonds located? So let's look at a completed job. So successful completed job, and you guys are still with me in teams, right?
Yes, sir.
Yes,
Okay.
sir.
All right, just checking.
I
Thank you.
believe so.
Okay, good. You should see no errors.
Yes, sir.
Okay, good. A successful job, computational job has what? No errors. I want to make sure you guys know this. This is where I stopped the last point. All right. It's very common for errors to come up. All right. That's okay when you get an error. Just contact me as soon as you can. I can go back and try to figure out. Sometimes there's a hydrogen missing in your structure. Sometimes the code was typed in wrong, or there's an extra space, there was a period, there was a comma or a hash mark or something that was put in that was not supposed to be there. All right, so beware of that, but it's okay when errors do come. So this is the warning, is that you don't want to start this late, because what's going to happen if you get a lot of errors and this is due in 4 days, you might run yourself stressed out, or you might put yourself in a situation where I just cannot help with the errors that's coming up with all the other things that I have to do as well, right? So my advice is to start early on this, right? You guys got probably up to a month, and a month is about what you would need. Now, if everything runs smoothly, you might get this done in a week, 2 weeks, right? If you do something tonight, the next day you get a new structure, you submit the second job, you get a new structure. You could be done. It could be just bang, bang. But I know for a fact that it's not common for computational work to go that smoothly. So be prepared for that. And if you need to, please contact me with any errors, all right? This job went well. So once I have a good job that had no errors, I'm going to go ahead and take a look at the log file. All right, this is the file that Avogadro can read to open up your data. So you want to go ahead and click on that, and you want to download it. It's going to download us up here. I'm going to open it in folder, show in folder. All right, I'm going to take this azo switch. I'm going to cut. Go to teaching, 4-10, fall 2020, computational project. I'm going to paste it here. All right, save the file wherever you want to. Then you want to come to Avogadro, right? And again, this program is on the machines in 211. Go ahead and make a new window here. And go ahead and open and find that file, right? So that's going to be in my computational practice right here. Okay. And your file should not only open where you see your molecule, and the molecule that will open from that log file would be optimized. All right, so that means that this is the preferred geometry. Right now, there's no solvent, so this is the preferred geometry in gas. But most importantly, you get this window over here on your right-hand side. So you guys look at the difference. When you're building a molecule, you don't have that, right? But my completed job does. Can anybody tell me why I'm seeing this now? Because I asked for 2 things. Not only did I ask to optimize the geometry, that's the op line, but I also asked for the frequencies, right? So now I have the frequencies on my right-hand side. Can you guys still hear me in Teams?
Yes, we
Yes,
can
sir.
hear you.
Okay, just checking because I was talking earlier and nobody heard me. All right, now this job has an issue. And the issue for this job, and I'm so glad this came up. I'm telling God is working with me, or working with us, I would say, this semester, because I need this as a teachable moment. I got this negative value here. So this tells me that this structure is not a ground state structure. Instead, it's lies somewhere as a transition state. All right. And for this course, we're not doing transition state chemistry. I'm asking for ground state, the lowest optimized, the lowest energy ground state, true conformations in solution, right? So that means if you make this molecule and you let it sit for a day, you guys let these things dry or whatever. This is the preferred conformation I'm asking for, not these type of structures. All right. So if we do get a job back that's imaginary, what you're gonna do is just find where the imaginary frequency is at. So this is telling me somehow this carbon is not really optimized, and we can kind of look at it and see why, right? So most likely this hydrogen probably wanted to be staggered, but it looks like it's eclipsed to that, right? Can you guys see that? The H and that carbon are directly in front and behind each other. So if I stagger that bond, I probably got the best structure. So this is telling me that there was a small error in the computational job, right? But let's keep moving forward with this because everything else should make some sense. That's a small mistake that popped up. So I want to know where my carbon nitrogen triple bond shows up. And you guys have those numbers committed to memory, right? Carbon nitrogen triple bond should be 2250-ish. So let's go down to that. Let's find a 2250. Yeah, we got 23. Okay, we didn't get 25 exactly, but 23. Click on that, hit start animation, and you see that that frequency matches up perfectly with what? The stretch of the carbon nitrogen triple bond. All right. I'm also going to ask you information about the nitrogen double bond. And they typically show up around 14, 1500. So let's play around. Let's see what we can get here. Looks like 15. Yeah, this is probably the best number here. This 1582, if you guys can see here, I can clearly see that nitrogen double bond stretch is accounting for that frequency. All right, so that's going to be the way that you guys want to report back on indicated data, but you also can click here and show spectra, and you'll get like a pretty somewhat decent IR spectra, and you guys can match that up with the one you get from your machine. All right, they're not going to have all the, they're not going to be broad, they're going to be just lines, but they're definitely telling you the relatively abundance. Right? All right, so that's your triple bond, some of your carbonyls and different things like that. All right, CH stretches. Okay. Is there any questions so far? There's another program I'm gonna look for that could probably generate a better looking IR, but for the most part, this will work. All right. Is there any questions so far on how to use the software or the data to do some of this work? Right. Is that a yes or no?
I have a
Dr. Cooper, I have a
question, Dr.
question.
Cooper.
Okay. Go ahead. Go ahead. Sure.
I can go first. So my question was, if we were to start right now on the project, what would be the first thing we would do?
Yep. If you want to start right now, build your molecule. And so you can go to moview.com and build this molecule in, right? You can draw it 2D. So I did that earlier. I'm sorry. I didn't want to do it again, but let's do it again real quick. This is a
So
little,
we're drawing the, so we're drawing the molecule you gave us, the one we have.
that's right. So
Okay, so the one that we, okay.
Yep. I'm so sorry. I didn't mean to cut you off. I have a tendency to do that. I'm sorry. But yeah, start with the molecule that you have. It should be a hydrazone. It's probably going to be a nitrile or a. I'm going to draw the nitrile this time. I'm sorry. I'm going to draw the keto ester version of this molecule. All right. So once you draw in your compound of interest, hit 2D, convert from 2D to 3D, and you're going to get this new structure over here, and it should be structure that you're interested in. Now, there's a lot of mistakes that happen, right? There's a nitrogen double bond that's not supposed to be there. There should have been a carbon nitrogen double bond, but it's okay. Just take it the best you can, all right? Because this program doesn't generate Gaussian files. It just generates a, I guess you would say, a visual file or a version of this that can be read into Avogadro, so you don't have to start from zero or start from scratch. So I'll go ahead and go to Tools and hit Mold File. I'm sorry, Tools and then Export as a mold file. And then you want to save the mold file in some place that you can find it. I'm going to go back to my computational folder here. I'm going to save this as keto ester. All right. Then you want to get access to Avogadro. All right. So this program here, I'm going to go ahead and open a new one. I'm going to hit open here. I'm going to go ahead to my computational folder and pull out my compound. And from here, if you want to, you can fix things up. So there should be a single bond here. So I'm going to click on nitrogen here. Single bond it and then double bond it there. And everything else looks pretty good. Oh no, something else is wrong. There should be a double bond. There should be a. It made the tautomer, which is cool. Actually, it's something I was interested in. Right. So this is the structure that I gave you guys on paper. All right. I'm gonna hit this E, which is just it's saying bring the energy down, which is the same thing as saying optimization. And you can click on optimization here. You kind of see how it's doing a little bit. This is Vesper theory. All right, so this is not high level quantum mechanics, but this is preferred for starting off. You at least want to start with Vesper. Okay, so hitting that will get you a structure that's pretty close to maybe the ideal structure. I'm going to stop that, and then you're going to hit extension and then hit Gaussian. And this is where you would save keto ester. I'm going to call this example. In the gas stage first, you are fine to go right to optimization, but typically you would do these two things in different steps. So I would do geometry first, then frequency. But it's okay for these small molecules to go right to the frequency. Okay. This basis set is a bit small, but it's okay. This theory is kind of is ancient now, but we'll still use it for this course. And once you have everything in, hit generate. All right, you want to save this Gaussian file in a folder. All right, so I'm going to call this ester keto example. Hit save. Then I need to go to cgrid. I'm going to go to my dashboard. I'm going to click on Gaussian 16. I'm going to name the job as the keto ester example. I'm going to put it in this project folder. I made the folder. You can make your own folders. Just make sure you can find where it's located. You want to make sure that you grab the Gaussian input file. The allocation is default is fine. Make sure that you guys are using the expanse resource. I'm going to click on this area here to change my time to 120 minutes. And I'm going to put in 100,000 physical memory and hit save and launch. Right? Typically, these jobs are probably run overnight, right? But they might be done sooner. There is a way to get email information. I didn't do that, so let's go ahead and redo that. Sorry. So let's say I'm going to resubmit the keto ester job.
Dr. Cooper, I have a question. This is being recorded, right? So we
Yep,
can go back and like reference exactly how to do each part.
yep, this is recorded. Yes, ma'am. That's correct.
Okay, will you be sending it out like as soon as we get out of class?
I can. It's going to take a minute to process the file, but I'll try to.
Okay, can you at least send it like sometime before the weekend?
Yes, I'm going to try to do it today, and if I don't finish, I'll try to keep working on it home. So
Okay.
I'll get it to you guys today. All right, there should have been an email. Maybe things has changed. I'm gonna hit save first. There should be a way to okay, maybe not. I think they might have guess they don't do that anymore. There used to be a way that you can email this to yourself, or you get to. All right, I'm gonna go ahead and hit save and launch on this one too. And your workspace, you can see that I got these jobs going, right? These are all the different jobs that we're running. Okay, let's talk about Avogadro really quickly and how to get access to that. All right, it's right here. I don't know what I'm spelling there. Sorry, I couldn't see. Computer's moving slow. This is how Avogadro looks, right? You click on the download, and you can download to that your personal machine. However, the machines in 211 also have Avogadro already downloaded. Those are only machines on campus I know that have it outside of the one I'm using. Teach you guys, right? And that's it. Mode view, you don't need software. It's just a web page. So you can build in, get this, and then save it as a mode file, open in Avogadro, generate a Gaussian file, come back to Cgrid, and send your computational jobs off, right? And I'm not too sure if you guys saw this part. But the whole basis of this is that you guys are going to start to compute, depending on if you have the nitrile or the ester, some of the key IR features and UV vis features, right, of these molecules, right? And hopefully from the one, if you do go on to do the second step of this, you'll be able to tell me which form, which polymer are you in. All right, am I in the azole polymer because you have a azole frequency that might match, or you might be in the hydrazone. You might have a amido, this carbon nitrogen double bond frequency that match, right? And if so, then you can make a conclusion that the conformer is in, or the molecule is in this conformer or in that conformer. Okay. So everyone will compute both structures. But synthesis, you only need to do this. This is mandatory. This is bonus to take it to the second step. You get either one of these two forms once you do the second step. All right. Every step is a 1-day reaction. So this is 1 day. This is probably the tediousest. This is the most tedious step. This is the easiest step. Once you have this, all you do is take that compound, the other compound, and you dissolve it in ethanol and you heat it for about 3 hours. You stop, collect the crystal, let it dry, and you either have this or that. All right. But because of social distancing, I didn't want to push you guys to keep coming into the lab because I could keep creating dangerous scenarios. So it's only mandatory to do the one synthesis molecule. All right. Does that kind of help you guys? I got a list of instructions and I'm trying to make it not done. I'm sorry it's taking me a while. I just got so many things keep popping up for this class and that class, and it's just a lot. So I'm definitely behind on a lot of things. But I'm working on it. It's in the background. I'm hoping to have it done soon. But this video will be released. If there's no more questions from anyone, you guys are good to go. I'm probably going to do this on, well, for sure, I'm going to go ahead. If my test is negative, then the lab will be open back next week. And you guys are more than welcome to do whatever you want. You could come in and start working on your derivatization synthesis. Or you could come in and start working on your unknown number 2. Or you could come in and, well, that's the only 2 other things to do. That's it. But I'm also going to make myself available online. So if you're starting your computational stuff and you have questions, you're more than welcome to say, hey, Dr. Cooper, can you help me look at this molecule? Can I make sure everything is okay and all that? Keep in mind, and I think I sent this to you guys as well, before you can do your computational, not computational, but your derivatization project in lab, your synthesis, you have to have all your calculations done. All right, so please make sure you run that by me before you come to lab on Tuesday. All right, if you don't have your calculations worked out, I'm not going to let you just go forward with the lab. We don't have a lot of reagents and solvents and all that, so we need to make sure that we are prepared to use them. Let me see if I can open that instructions. It should be it right here.
Oh, Dr. Cooper, I might have to leave soon because of time.
That's fine. It's recording. If you got to go, I completely understand. I'm just trying to, all this stuff should have been sent. I'm just trying to make sure I don't have to double repeat or for people to say they didn't know that they needed to have this stuff done. That's just my number one concern. All right, there should be a sheet that says the derivatization projects, right? There should be a stoichiometric table here. All right, please make sure you guys proceed with calculating needed reagents to do this chemistry. All right, the steps are here. I'm asking you guys to start from anywhere from a gram to half a gram. All right, half a gram would be even more preferred, just so that we don't use up a lot of stuff or potentially make a lot of waste. But if you feel like, hey, I'm a person that, like need bigger amounts, you're okay to use up to a gram. Okay, so please make sure if you're going to start your synthesis project that you guys have your math worked out. All right, is there any other questions from anyone? Okay, good. All right, I'm going to go ahead and stop the recording so that can get processed so I can try to get that uploaded for you guys.